Hello everybody, my name is Yassine Sadat and this is my fourth term science project. My project for this term will be talking about the life cycle of stars. A star enters the first stage of its life cycle as a ball of gas and dust, also known as a nebula. Then gravity pulls the gas and dust together into a sphere, which is known as a protostar. As the protostar gets hotter, the hydrogen changes into helium in a process called nuclear fusion. Then the star becomes a main sequence star, which is second and longest stage of its life cycle. During this stage, energy is generated in the core of the star as hydrogen atoms fuse into helium atoms. This process releases a large and continuous amount of energy. The size of a main sequence star will change very little as long as the star has a continuous supply of hydrogen atoms to fuse into helium atoms. After the main sequence stage, when a star runs out of hydrogen in its core, the center of the star shrinks inward and the outer parts expand outward. For medium-sized stars, like our Sun, the star's atmosphere will grow very large and become cool. When this change happens, the star becomes a red giant. However, if the star was very massive, it becomes a red supergiant. Red giants and red supergiants are typically larger and cooler than most main sequence stars. When a red giant reaches its final stages of the life cycle, it becomes a white dwarf. A white dwarf is a small hot star that is the leftover center of an older star. A white dwarf has no leftover hydrogen left and can no longer generate energy by nuclear fusion. White dwarfs can shine for billions of years before they cool completely, which in this case they will turn into black dwarfs. When red supergiants die, they explode into a large explosion called a supernova. A supernova is a gigantic explosion in which a massive star collapses and throws its outer layers into space. A supernova explosion is so powerful it can outshine a galaxy for several days. Following a supernova, the center of a collapsed star contracts to form a new star. The mass of this new star is about 2 times the mass of the Sun. This is called a neutron star, a star that has collapsed under gravity to the point at which all of the star's particles are neutrons. If a neutron star is spinning, however, then it is called a pulsar. A pulsar sends out a beam of radiation that sweeps across space, and this beam is detected on Earth by radio telescopes as rapid clicks or pulses. If the center of a collapsed star has a mass that is more than 3 times the mass of the Sun, the star may contract further because of the strength of its gravity. The force of the contraction crushes the dense center of the collapsed star and leaves a black hole. A black hole is an object that is so massive that light cannot escape its gravity. Black holes can be detected by X-ray telescopes on Earth. In 1911, a Danish astronomer named Einar Hertzsprung compared the brightness and temperature of stars on a graph. 2 years later, American astronomer Henry Norris Russell made some similar graphs. Their efforts were combined to create the Hertzsprung-Russell diagram, a graph that shows the relationship between a star's surface temperature and absolute magnitude. The HR diagram became a tool for studying the lives of stars, and it shows not only how stars are classified by brightness and temperature, but also how stars can change over time. Some famous stars include Rigel, Polestar, Betelgeuse, Antares, Arcturus, the Sun, Tau Ceti, and Alpha Centauri. All main sequence stars follow a pattern across the HR diagram. As indicated by temperature, red stars are usually colder than blue stars. However, blue stars do not last longer than red stars because they use their hydrogen up quickly. Thank you for watching.